All right, here we go with law of cosines. This is the derivation of it, like how you get it. If you, I think it's worth watching and trying to piece together because the law of cosines looks like this. It's horrible, it's ugly, but it works all the time, right? It works to solve any triangle under the sun ever. It's ugly. And so I think the derivation helps you A, figure out how to use it, and B, see the nuances of where it comes from. It's not something that you need to know. If you think you can demonstrate it on a test or a quiz, I'd give you some extension points for that. Great. So if you're not interested in the derivation, just jump ahead a little bit. If you're interested in the derivation, put your seatbelts on and check this out. So I'm going to move myself so you can see things, but I kind of feel like Two-Face now. So here's the basic idea, is that we have our triangle chunk, right? And you have side A and B and C, right? And this piece we might call H for the height of it. Great, fine. B, since this drops down, B gets broken into two pieces. And one of those pieces we're going to call X. And what's left over, the other chunk, is B, the whole thing, minus X. That's this piece, right? It's B, the whole thing, but cut off this bit. And what you're left with is B minus X. Cool? All right, so that's that piece. If you look at just this inner chunk like this, we can take the idea of Pythagorean theorem is the hypotenuse squared equals both of the sides added up, squared, and then added up, right? So here C is still C, but one of the sides here is H squared, and one of the sides here is B minus X, so B minus X squared. So hypotenuse squared equals each of the sides squared and added up. So that's what this mess is. Cool? Now, also, we want to say this about these pieces. Sine of C, so the sine of this is opposite over hypotenuse, right? So sine of C is H over A, sine of C is H over A, and cosine of C is adjacent over hypotenuse, X over A. So these pieces are there. Okay, we're going to use those in a second. We're going to turn them around a little bit. Multiply A on here on this side, multiply by A over here, and this turns into this, and this turns into this. Right? Take a look at them. Make sure that makes sense to you. Multiply by A. A turns over here, and I've just like flipped them over. Okay, fine. So that's our starting point, yeah? So hold your breath. Here we go. I'm going to take this piece and substitute in some pieces. So here's C squared still sitting right here, and here's C squared. But instead of H, we're going to call H by its other name, right? By A sine of C. And this was H squared, so it's A sine of C squared. We're just substituting it in that nickname. Well, we're going to do the same thing for X, right? Now this one's going to get ugly because X is equal to A cosine of C, and we're putting this in place of X, but B's still hanging out there, so it looks like this. Oh man, that's awful, right? Great, it's going to keep getting worse. If you square this is like saying X times Y squared. It means X times Y times X times Y, so you get two X's and two Y's. So we're doing the same sort of thing here, right? And so for this blue part, you're going to get A squared sine squared of C, which just means sine of C squared. And then this piece, we're going to multiply like a binomial, right? So this turns into B minus A cosine of C times itself, since we have that squared there. And then we FOIL it. Ba-boom, 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 ba-boom. The blue part will stay the same, and the red part will turn into this. B squared, A squared cosine of C when you do this last part, and you get two of these AB cosine of C when you get this times this, AB cosine of C, AB cosine of C. They're both negative, and so that's where the 2 comes from. Oh. And then we just do a little rearranging. So we're going to rearrange with keep the sign there. We're going to just move this piece, the back part of this. We're moving this up front, and we're moving this b squared to the back. We're just kind of flip-flopping things around, right? We did that because this is a really interesting, it's called a trigonometric identity. And if you plug anything in your calculator for C, regardless of what that is, you'll notice that sine squared of C plus cosine squared of C, if you put 10 in there or 20 in there or whatever in there, you'll always get 1 out of that. So we've factored out an a squared. This becomes 1, which is pretty cool. And then you're left over with this b squared minus 2ab cosine of C sitting at the end. So this piece, the big trick in there, like if you throw anything in your calculator, you go sine of 25 squared plus cosine of 25 squared, you get 1. It doesn't matter what you put in for the 25. And that's why this piece turns into 1. It's just because it's a trigonometric identity. You might have to take on a leap of faith for now, but before we get deeper into trig. But it's kind of a neat thing. And so this really boils down to this, which is the law of cosines. So here we go. We're going to try to use it. So c squared equals a squared plus b squared minus 2ab cosine of c. There's no great song for that, Mags. You should make up a song for it. But when this is great if you have all 3 sides and no angles. You can find the angles, or if you have 2 sides and the included angle. So let's try it here. Oh, this was the one that we couldn't do before. All right. So the only place that you see an angle in here is cosine of C. Yeah, this is C. This is C, right? All of these are A, B, C. Those are all sides. Sides are lowercase. They're small letters. They're small variables. Capital variables are always the angles. So A, B, C, right? So this is the only place that we see an angle. So if we're trying to solve this, solve means find all the sides, find all the angles. This is the only spot we see an angle. So this is going to be our C, big C, right? So this piece is going to be our C because it's across from C, right? So the setup will look like this. C squared, and we don't know C squared. I don't know what that is, but that should equal a squared plus b squared. It doesn't really matter which one of these two you call a and b at all. So I'm just going to put 35 squared. We're going to call this a because I see it first, and we're going to call this b. So 35 squared plus 30 squared minus 2 times each of those. 2 times 35 times 30 times the cosine of that included angle, C, which is 110. Cool? And you crunch that and you get C squared. Be really careful when you crunch that, right? Square this, add them, get a number. Multiply all of this, get a number, and then subtract, right? So you try it, I'll try it, and we'll come back with our answers, yeah? So for just this piece, so far I've got 2125 minus, so got negative 718. Plus 2843. Cool. And that's C squared. So now we got to take the square root of it. You end up with C is like 53. Does that look approximately right? Like this could be 50 if these are 30 and 30. Yeah. Ka-ching! Hardest part is setting it up, right? So let's try a couple. This is the one we already did. So here's the solutions for it if you want to walk through that with a little less chaos in it. And let's try this one together if you are game, right? So we're trying to find the measure of angle T. All right. So take a second, take the take the law of cosines. Here, pop it back up here for you, and we'll try it out together in a second. Okay. All right. So I know that this is the only spot in law of cosines where you see an angle. It's right here. So this has to be the opposite side. This is C, so this has to be C. So 7 has to be C, little c. So this is going to be 7 squared is equal to, doesn't matter which these other sides are, doesn't matter at all. So let's just call this one A, call this one C, this one B. We know this one has to be C, these two don't, their order doesn't matter. So this is 13 squared plus 11 squared minus 2 times 13 times 11 times the cosine of C. And in this case, I don't know what C is. It's angle T, right? It's T, so I'm going to call it cosine of T. And it's our job. We're trying to find that angle. It's our job to isolate cosine of T and then take the inverse cosine. So we have to get rid of all of this stuff, which is kind of hard. So let's crunch some numbers and just put a few things out there. This is 49. This is 169. This is 121. This is 2 times 13 times 11. This is 286. I don't know what T is, so I'm going to go times the cosine of T. We have to deconstruct this and isolate cosine of T. So first you're going to have to subtract this off of both sides, subtract this off of both sides, and then divide by this, right? So I suppose if you added the 169 plus 121, if we added this bit, you'd get 290. So this turns into 290 minus 286 cosine of T. And we got 49 still sitting over here, right? This is sort of like saying 10 equals 3 minus 2x. You can't just subtract, you can't combine these two. You have to first subtract this 3, make it 7, and then divide by the negative 2, right? We're doing that same thing but with uglier numbers. You'll be fine. So let's give it a shot, right? So we're going to go 49 minus 290. So if you subtract that, you get negative 241 off of this side, and left over is going to be negative 286 cosine of T. Right. If that was a little too fast for you, we just went minus 290 on this side, and minus 290 on this side, and this canceled, yeah, and this gave us this piece. Cool? So now we've got negative 241 equals negative 286 times cosine of T. And so with that, we've got to divide by negative 286. So we're going to go divided by negative 286. And, oh, sort of strange looking. We get positive 0.842 equals cosine of T. Great, that's the funky decimal associated with the angle T. So now we have to take the inverse cosine. To find T itself, T is going to be the inverse cosine of that funky decimal. 0.842. And that's going to give us 32.57 degrees. And that's a reasonable angle for that, right? Ching. Well, let's check it first. Ah! Oh yeah, 33. They just rounded. Neat. That's law of cosines. Yeah. What I want you to try is, the law of sines is pretty straightforward. So these aren't too bad. These are find the value, like use the angles and sides to find sides, find a side, find a side. Here, find an angle, find an angle, find an angle, and then the real battle commences here, right? This is find missing side, this is find missing side, find missing side, find missing angle. Give it a shot. If you think you are on the money, check out the ambiguous case. Sometimes there's two things that could happen. It's not something you have to know at this point, but it's pretty neat. So you got your work cut out for you. Go for it. Solutions are there on the VLE as well. So be good.